Welcome back to Survey of Engineering. We are now in our Material Science and Engineering unit. Today we'll be talking about plaster mixing and the safety that accompanies that. Here are your portfolio questions for this video. Number 1, what are the safety precautions that are necessary for mixing plaster? And why do we need to test different mix ratios for plaster for this unit? So let's talk about what is plaster of Paris. Basically, it's a dry powder that's formed from gypsum. Gypsum is a crystalline compound that's formed from calcium sulfate and 2 water molecules. So we make plaster of Paris by heating the gypsum in order to take off some of the water from the calcium sulfate to make calcium sulfate hemihydrate. That means somewhat hydrated, a little bit of water. When we add water back to this powder, it rehydrates or adds water into the structure, and it can then form the crystalline structure of the hardened plaster. And as it does this, it releases heat. So here's the chemical equation. We have our calcium sulfate hemihydrate with a little bit of water plus some water molecules goes to this reformed gypsum, and we see that heat comes off as we do that reaction. So, plaster of Paris mix ratio. The manufacturer, if you read on the bag of the plaster of Paris, tells us that we want a 2-to-1 plaster to water mix ratio. This is by volume. That means that if I have 2 cups of plaster, I want to mix it with 1 cup of water. That means 2-to-1. We will be experimenting with different mix ratios because we want to understand how these different mix ratios will react to different forces or different loads that we'll put on them. Drier mixes that means that there's more plaster to water. This tends to result in more dense and stronger plaster, but it also means that it has a much faster setting time, and it may mean that you don't quite get it fully mixed in, and so there could be voids or parts of unmixed dry mix that could create a greater weakness. It also means that your beam will be heavier, and that is not great for our strength to weight ratio. If we want a lighter beam that has stronger properties, if we have a very dense beam, that lowers our strength to weight ratio. A wetter mix, that means that we have less plaster to water. That results in a less dense plaster. It also means that it might be a bit weaker, that it will be weaker, and that we have a longer setting time. That means that we have a little longer time to mix, and so that we have maybe more thorough mixing. So these are some trade-offs that you need to think about and that we're going to experiment with to see how you want to ultimately decide on the mix ratio you need to have for your beam that you'll be making. So this is how we're going to test to determine what our preferred mix is. We're going to use something called impact testing. So we're going to make small pucks of plaster with different mix ratios and then place them in our little impact tester and drop the weight on top of them, giving it an impact. Now if we change the height of this arm that we're dropping on top of our puck, that gives us control over the force that the puck feels in the impact. So, important things to consider for safety while we're mixing plaster. We always have to wear safety glasses, and if you're not in a well-ventilated room and being very careful to not create dust, you should wear a dust mask so that you're not breathing any of the plaster in. Always wear gloves. And don't let bare skin to have a long exposure or prolonged exposure to plaster. So any that gets on your skin, wash it off quickly. Always, always, always use a stir stick to mix. Never mix plaster with your hands. The heat that is created by the reaction can be enough to burn your skin, and it can cure around your hand and cause that burning. It could cause serious injury. Also, we want to be concerned or careful that we never put any plaster down the drain. So we'll make a wash basin by lining a 5-gallon bucket with a plastic bag and filling that bag with water. So when you're cleaning anything that has plaster in it, plaster mixture in it, you're going to wipe it away or scrape out as much as possible with a newspaper, throw that in the garbage, and then you rinse your container or your whatever it is you're cleaning in the wash basin that we've created. Before you mix, each time you're going to make a test puck, you'll label the bowl that you're going to put your puck in as your mold with the mix ratio that you're doing. You're going to measure up the side 3/4 of an inch and make a mark. And this is the line that you're going to fill to. We want to make all of these pucks uniform in volume or uniform in size so that we are controlling for any other variables and we're only changing the mixed ratio. Then, after you've done this, you're going to apply a thin film of petroleum jelly to the bottom and the sides of your bowl. This is going to help the mold release the plaster once it's cured. Now, please make this a very thin film. We don't want globs and goop of your petroleum jelly. This will lead to not very good results when we're puck testing because we'll have incorrect and non-uniform geometries. Okay, so here is how we're going to mix plaster, and I'm going to show a little video of actually me mixing the plaster. So here's the video of me mixing the plaster. I've already marked the side of my bowl. You can see inside I've marked the side of the bowl, and I'm going to go ahead and take some petroleum jelly and smear it around inside the container. This is going to be my mold for my plaster. So I'm trying not to make it too gloppy, get kind of a thin film, but still have some good coverage for my container. Now I've already measured out a volume of water. I'm using 1 cup of water, and I'm going to put it in my mixing container. And I'm going to use a separate measuring cup because I don't want to get any water in my plaster at this point. So a dry measuring cup to measure out my plaster. And I've already decided what my mix ratio will be for this purpose. It's about 1.5 plaster to 1 water. So I'm pouring this into my mixing container, being careful to kind of break up the lumps as I pour. It's also a good idea to take a dry spoon and break up any lumps that you have in your mixing container of your plaster. Sorry, this is not my mixing container. This is my dry plaster container. So when I am going to put my plaster into my water, it's very important to not dump it in all at once. You'll see kind of at the end of this that I have a little clump that jumps in, and that doesn't work out too well. What you want to do is carefully tap the side of your plaster container to gently sprinkle it into the surface of the water, and watch that it sinks down into the water before you sprinkle more in. There's sort of, you can't do this too slowly but too quick, and you don't want to do it too quickly either. You need to do it fast enough so that we get it in before it starts to cure, but slow enough that the plaster has time to sink into the water before we want to stir it. So carefully just tap the sides and sprinkle it into the water and let it sink down in. This is helping once we start mixing, it starts the curing process. So giving it this little bit of time to have exposure to the water, we let the water get into the gypsum before we start curing it. So I'm just tapping and carefully letting it sink down into the water. This is important to not hurry, and also to sort of not sprinkle it all in one place. Otherwise you'll have buildup and you'll have this sort of mountain in the middle of your container, and that will leave dry plaster on top of your water. And there too much went in, and now I'm sort of stuck with some plaster that's not wanting to sink down in on the top of my water. So that's not what you want to have happen. At this point, you want to let it sort of sit a little bit. Actually, tap the container, and we're going to get air bubbles out as much as we can. So you can tap it by hitting the side of your container or just by banging it onto the tabletop, and that gets the air bubbles out. We want air bubbles out so that we don't have any of those in our cured plaster, because that will be weak spots for our plaster. So once you've tapped it and made sure you get as much of the air bubbles out as possible, you want to let it sit for a couple of minutes, not too long, because we don't want it to start curing, but that just gives it some time for the water to get absorbed. And then once it's sat for a little while, you go ahead and start mixing. And we don't want to mix vigorously, we just do a careful side-to-side motion so that we're breaking up the lumps and we're distributing the plaster in the water, but we're not introducing any air bubbles. So just carefully and slowly mix back and forth and try and get any lumps out that may have formed. And you can feel if there are lumps that you just want to sort of smash those against the side and get that nice and mixed so that you have a pretty uniform plaster mix. Any non-uniformity will result in weaknesses in your plaster, and that's where breakages will occur. So once you have it mixed, you can go ahead and pour it into your mold that you've already prepared. You don't want to pour too, you don't want to splash it, and you only fill it up to your line that you have in your container, because that's our fill line. Once it's in your container, go ahead and tap it on the bench to get out any air bubbles. And then you're going to allow that plaster to set for 20 to 30 minutes. After it's set and cured, you're going to take it out of the mold and then allow the plaster to cure for 1 to 2 days. So when you get into your groups, you're going to decide on the mix ratios that you'll be testing. You can collaborate with other groups, and that way you in your group will test 3 different mix ratios. So collaborate with another group and you guys agree on different mix ratios to test. That way we have more differing ratios that we can see the results of. You will have measuring cups and spoons to measure the plaster and water. There are 2 separate sets. Please don't use plaster spoons to measure water. Otherwise we'll get water in, or vice versa. Otherwise we'll get water into our plaster bag. We don't want that because we don't want it to start curing. Important conversion factors to think about as you're calculating your ratios. We'll give those to you in class, but 1 cup is 16 tablespoons and a tablespoon is 3 teaspoons. And so be ready to mix plaster in next class time, and you will want to not wear any nice clothes in case there's any spillage on your clothing. See you in class next time.